Right, they want us to find the zeros and graph this equation, this quartic equation, and I'm assuming they don't want you to use your calculator, so here's how you do this. If you could use your calculator, like on a final exam, just plug this in, look at your graph, which is going to be something like that, or like that probably, most likely, and find your zeros. Find whichever ones, like if those are your zeros, just find one or two of them that are easy to see. Use synthetic division to find the other ones, and then solve for that. But since they don't let us do that, we're going to have to figure this out by ourselves. So, here's the rule. If you use this number right here, the factors of that number are called P, and the factors of this number, the leading coefficient, are called Q. This is the rational root theorem, or the rational root test. The theorem says if there are rational roots for this particular quadratic, then they will be of the form P over Q. That's what the theorem says. So you take all of the numbers. 24 unfortunately has a lot of factors. Fortunately 1 doesn't have a lot of factors. So all of my options are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. That's a lot of things to check. That's why it's good if you know one of them right off the bat. It's much better. So theoretically I would have to check all of those factors until I found one that worked with synthetic division, and then break this down, use synthetic division to reduce that to a cubic equation, find another factor, use synthetic division to reduce it to a quadratic, and then you could factor it or use the quadratic formula to find the remaining zeros. Usually when they give you a problem like this, two of them are real and two of them are sometimes two of them are real and two of them are imaginary, or sometimes two of them are rational and two of them are irrational, which means you'd have to use the quadratic formula or complete the square. Alright. So we're just going to go ahead and start by, I like to just plug in numbers here. I'm going to try 1, because usually it's an easy number that works. Let's try 1. Would 1 work? 1 plus 1 minus 2 plus 4 minus 24. Nope, that's not a solution. So 1, not a solution. Neither is negative 1. You can see that negative 1 isn't a solution either. Let's try 2. What's 2 to the 4th? That's 16 plus 8 minus 8. Ooh, I like that. Plus 8. Ooh, I like that. Minus 24. Let's see. Those cancel each other out. Hey, look at that. 24 minus 24 equals 0. So what's one of my rational roots?
X minus 2.
One of my rational roots is 2. Since one of my rational roots is 2, I'm going to use synthetic division to break this quartic into a cubic. So synthetic division, I think I did that the wrong way, didn't I? Synthetic division looks like this. Take your leading coefficients, 1, 1, negative 2, 4, negative 24. Make sure you put a 0 in there if you have to hold a place for any of them, which we don't in this case. And now bring this down, multiply here, put it there, add them down, 3, multiply here, 6, put it down there, multiply down, add down, 4, 2 times 4 is 8, add down, which is 12, 2 times 12 is 24, add down, I get 0. Since I got a 0 there, that tells me it's a 0, because f of 2 equals whatever you get there in synthetic division. It's one of the things that you learned way back when. There's our new equation that's a cubic. Now let's think about it like this. X cubed plus 3x squared plus 4x plus 12. Let's try to do another one. Let's try to get another one. That's a 0. And by the way, it could be 2 again. You could still have another 2 could be a double root. So you can start by trying 2 first. Can look at it, and 1's not going to work, nor is negative 1, which we already knew that because it didn't work for the first one. Let's try negative 2. Let's see if that works. If I plug in negative 2, I'm going to get negative 8. I'm going to get positive 12. I'm going to get positive 8. Ooh, I like this. Ooh, so close. Oh wait, I did something wrong. This should be a negative 8 right here, shouldn't it? Because I plugged in negative 2. Dang it, that doesn't work. So negative 2 is not a root. Let's try 3.
Right? Compute.
All right, let's try negative 3. I'm getting some indications that negative 3 will be good. So if I do negative 3, this would be negative 27. This would be positive 27. Oh, nice, nice. This is negative 12. What? Look at what happens. Boom. Those all cancel out. So what's going to work? Negative 3 is going to work. So here's what I do. I'm going to take right here, I'm not even going to rewrite this. I'm just going to turn this into another synthetic division and use negative 3 now. And I'm going to bring the 1 down, multiply negative 3, 0, multiply 0, 4, multiply negative 12, 0. So what's this equation right here? I turn my cubic into a quadratic. It's x squared plus 0x plus 4. Uh-oh. Guess what this is right here?
That's
How many
cube
real
thing.
solutions does that have? That has no real solutions.
Oh, yeah. Oops.
Oh, yeah, because it would have to be an imaginary, right?
That's right, because what's going to happen if I set that equal to 0, you can see it's going to be x squared equals negative 4, which means x equals plus or minus 2i, and there are my solutions. So my zeros are positive 2, negative 3, and positive 2i and negative 2i. Those are my zeros.
All right.
Now the question stated, find the zeros and graph it. So when I graph this, let's go ahead and graph this now. So I'm going to have plus or minus 2i. So here are my zeros. These two zeros represent imaginary solutions, which means I'm only going to have 2 places where I actually cross the x-axis. Here's my x-axis. 1, 2, 3. There's one place. 1, 2. There's the other place. These represent other ones. And the fact that this is a positive 1, I'm using a little graphical analysis, means that it's going to, and it's a 4th power, means they both go up at the end. Now I don't know exactly where these are going to show up, but what I do know is it's going to go up on both ends. The end behavior is up in both directions, and it crosses here, and it crosses here. So it could do this, or it could have done something different. We don't quite know where the plus or minus 2i are going to be represented, but the rough graph of it would be maybe something like that. I don't think the teachers expect you to be any more specific than that. They just want you to know where it crosses the x-axis and know what the end behavior is, and the zeros tell you a little bit more
Also,
information about
couldn't we
that.
graph it?
And again, let me reiterate, if you were allowed to use your graphing calculator, don't go through the hassle of finding the p over q. There's no need for that. When you look at your graph and you see these right here, if you see 2 is one of your zeros and negative 3 is one of your zeros, just use synthetic division in here with those numbers, 2 and negative 3, and break this down into a quadratic equation by reducing the order of it through synthetic division. Alright, one other thing, if they wanted you to write this out as a product of linear factors, which they might, here's what you would do. X minus 2, because that comes from, if x equals 2 is my 0, then x minus 2 is my factor. X plus 3, again, because if x equals negative 3 is my 0, then x plus 3 equals 0 is my factor. And then the other ones would be x plus 2i and x minus 2i. Or if they wanted you to write it without the imaginary roots, you could leave the quadratic, which I don't think the teachers really want you to do that, but you could leave it like that. X squared plus 4. Because that's what that is right there. If you multiply those out, you get x squared plus 4.